What we're working on this week is trigonometric equations. And the first thing we need to go over in the first section is chapter 6, our inverse trig equations. Now, I said I was going to introduce somebody. Hold on. This is one of them. She sometimes hangs out with me when I do math videos. But her name's Pumpkin. That's real. So I have an orange cat and I name her Pumpkin. That's so original. I should have thought something else. But anyway, we're working on chapter 6, inverse trig functions. And hold on, she's got my paper here. I'll have to take it from her. That's kind of dangerous. But I'll see what I can do. All right, so let me switch the camera over. Yes, you do need to take notes. All right, so let's see. Let me get this away from her. Move. All right. All right. So inverse trig functions, you know this, you already know this. Sine of pi over 3 is equal to square root of 3 over 2. Now, if you reverse that, move. If you're, ow. All right, move. All right, so if you reverse that, I want to put the square root of 3 over 2 first, and I want the answer to be pi over 3. When you do that, that's called inverse sine. That's called inverse sine, and the answer is pi over 3. So when you do a regular trig function, you plug in an angle and your answer is a ratio. But when you go the other way, the answer is a ratio. No, what you plug in is a ratio, and the answer is an angle. Okay, it's reversed. And we've kind of done something like this before. You did this when you were solving for right triangles, when you were solving for the missing angle. You did it then, and we're doing it again. So I want to find the exact value of each of these problems in radians. Now, what you need to get out is you need to get out your unit circle with all the angles on it. You have a copy where this takes up like the whole page. So, for example, inverse cosine of 1/2. Inverse cosine of 1/2. Now, this is a ratio. We want to find out where is the angle that matches that ratio. So my answer needs to be an angle. So let's go up here to the unit circle. Let's go around till we find, remember, which one is cosine? Cosine is the x value. So where is the x value equal to 1/2? And you found it right there. There it is. That's where the x value is 1/2. And if you look at the angle is pi over 3. If I ask for it in degrees, it would be 60 degrees, but the answer needs to be in radians. So that will be pi over 3. But again, if it was degrees, the answer would have been 60. All right. Now this one, arc sine of 1. Now what the heck is arc sine? Arc sine is the same thing as inverse sine. Inverse sine and arc sine are two ways of saying the exact same thing. All right. So this just means, that's another way of writing inverse sine. And don't say, I guess you could say sine of the negative one, but that's not really how you say it. It's inverse sine. It's the same thing as arc sine. This was kind of, some trig books use this way, some trig books use this way, and trig books today kind of just tell you both, so you know they both mean the same thing. All right, where around here, let's see if we can find where the y value, because sine is the y value, where is the y value equal to positive 1? There it is right there. That's where the y value is equal to positive 1. So did you hear? So the answer, she wants to get out. The answer is pi over 2. Let me let her out. All right, go. Okay, here we go. Now the next one, inverse tangent. Now what's another way to write that? What's another way you could have seen it? Another way you could have seen it was arc tan. That would be the same thing. So we're going to look for where's the ratio, what angle would have a ratio of pi over 3. Now remember, tangent is the second number divided by the first, the y value divided by the x value. And if you look at this, I don't know why I keep picking on pi over 3, but the answer is here again. It's going to be this one. If you take tangent, it's root 3 over 2 over 1/2, which reduces to root 3. So tangent, I keep picking on pi over 3. I don't know why I did that. But the answer here, the angle would be pi over 3. And again, if it was degrees, it would be 60. Now, I made a note here. You can take the reciprocal of a ratio, but you cannot take the reciprocal of an angle, not an angle. You could take the reciprocal of a ratio, okay? So here, inverse secant. I know you don't like inverse secant. I'd rather change that to cosine. Well, you can change that to cosine, so that's going to become inverse cosine. Now, what do you take the reciprocal of? Remember, when you take the inverse of something, that right there is the ratio. So that is what you take the reciprocal of. So when you change this to inverse cosine, you change the 2 to 1/2. Where's cosine equal to 1/2? Daggone it, the answer is the same thing. It's pi over 3 again. It's pi over 3. So that's going to be pi over 3 again. All right, now next one, arc cosecant. Arc cosecant. Remember, this is a ratio. We are not going to leave that as arc cosecant. We're going to change that to arc sine. And we're going to do that by taking the reciprocal of this ratio. When you take the reciprocal of the square root of 2, it's 1 over the square root of 2. It is negative. And if you multiply the top and the bottom by the square root of 2, that becomes negative square root of 2 over 2. Okay? Now, this one's not going to be pi over 3. All right? Where is the y value? Negative square root of 2 over 2. Well, let's see. We go around the circle. We got to find out where the y value is negative square root of 2 over 2. It's right there. It's right there, and that would be 7 pi over 4. Now, the calculator is not going to call that 7 pi over 4. Instead of calling that 7 pi over 4, the calculator, and we should too, is going to take the easy way. Instead of going all the way around the circle this way, it's just going to go this way. Now, instead of going all the way around this way and calling it 7 pi over 4, what would it be if you went this way? Well, that would be in the negative direction. So instead of calling that 7 pi over 4, we're going to just call that negative pi over 4. It's the same thing as 7 pi over 4. We're just taking the easy way. So the calculator would give you this answer. Even though it's the same thing as 7 pi over 4, we're going to call it negative pi over 4. That's the end of this video. We'll return some examples that actually use triangles.